Deep within the fabric of space-time, where light dares not escape, two cosmic titans prepare for a dance of unimaginable power. Today, we're diving into the mesmerizing and cataclysmic event of black hole collisions. Buckle up for a journey into the mysteries of the universe. Black holes are born from the death of massive stars. When a star exhausts its nuclear fuel, its core collapses under its gravity, creating a singularity, a point of infinite density. Surrounding this singularity is the event horizon, the boundary beyond which nothing escapes, not even light. Black holes vary in size, from stellar black holes, a few times the mass of our Sun, to supermassive black holes, millions or even billions of times more massive, lurking at the centers of galaxies. Black hole collisions usually begin with galaxies colliding. As these galaxies merge, their central black holes are drawn together by gravitational forces. Over millions of years, they spiral closer and closer, setting the stage for the ultimate showdown. During this dance, the black holes emit gravitational waves, ripples in the fabric of space-time first predicted by Einstein's general theory of relativity. When the black holes finally collide, it's not just an impact, it's a fusion of unimaginable forces. In the final moments, the black holes' event horizons merge, creating a single, larger black hole. The collision releases more energy in the form of gravitational waves than all the stars in the observable universe combined emit in light at that moment. These waves travel billions of light years, carrying the signature of the event across the cosmos. But how do we detect these cosmic events? Enter LIGO and Virgo, advanced observatories designed to measure the faintest distortions in space-time caused by gravitational waves. In 2015, these instruments made history by detecting the first-ever gravitational waves from a black hole collision. These detections have opened a new window into the universe, allowing us to study events that were previously hidden from view. Once the collision is over, the resulting black hole begins to settle down. It's larger, spinning faster, and emits a final burst of gravitational waves called the ring-down phase. Eventually, it becomes a silent giant, invisible but forever altering the space around it. Nearby stars and gas clouds are pulled into the gravitational grasp of the new black hole, feeding it and potentially forming an active galactic nucleus. Black hole collisions are not just cosmic spectacles, they are vital to the evolution of the universe. They contribute to the growth of black holes and provide critical insights into the nature of gravity, space, and time. Every detection of a black hole collision is a leap forward in our understanding of the cosmos, answering old questions and raising new ones. Two black holes colliding is a testament to the power and mystery of the universe. It's a reminder of how much we've learned and how much there is yet to discover. Keep looking up, for the cosmos always has a story to tell.